Hello mortals. You are probably very small, compared to the size of the Earth. It would take you around 2 years to run a full circle around it. But at the speed of light, that time would become 13 milliseconds. To pass through the solar system, you'd spend around 10 hours at light speed. If we were to take the supermassive black hole from the center of our galaxy and put it in the Sun's place, it would engulf Mercury, and later the entire solar system because of its gravity. But what about the biggest known black hole? What if we throw it in the center of our solar system? 3, 2, 1. Go. Wait. Nothing changed? Where is it? Let's zoom out a bit. There it is, the magnificent hypermassive black hole, Phoenix A. It would take you a whopping 3 weeks of traveling at the speed of light in order to cross it. That is, if you would not die. First discovered in 2010, Phoenix A is the most gigantic black hole that has ever been discovered, and is located at the center of Phoenix Galaxy Cluster, around 8.5 light-years away. The mass of the central black hole is around 100 billion times larger than the Sun, while its event horizon has a diameter of 590 billion kilometers, that is about 100 times the distance the Sun and Pluto. This black hole was categorized as a quasar, 8.5 billion light-years away, and having 10% of the mass of entire Milky Way. For reference, the light coming from it that we are seeing right now, originated 8.5 billion years ago, when neither the Earth, nor even the solar system existed. 8.5 billion years ago our galaxy merged with a smaller one called Gaia, and took the shape that we know of today. In other words, this quasar is incomprehensibly far away. And you might ask, what exactly is a quasar? It's when a central galactic black hole is surrounded by a huge accretion disk, and due to all the friction going on, it starts to shine brighter than all of the stars around it combined. Phoenix A is so hyperluminous that it outshines the entire galaxy that it is located in. That's 150 trillion times brighter than the Sun, or about 10,000 times brighter than our entire galaxy, which, mind you, contains 300 billion stars. So yeah, ironically, the black hole from which not even light can escape, emits a lot of light. That's about as bright as our hope for cyberpunk. A stellar black hole the size of our Earth would weight as much as 1,000 suns. Make it as big as our Sun and that number becomes 200,000. The previously mentioned Sagittarius A at the center of the Milky Way has 4.3 million solar masses. And then there is our beloved Phoenix A, with a mind-bending 100 billion solar masses. It is so huge that even the biggest hypothetical star, the quasi-star, is just a little speck in comparison. But how do these cosmic behemoths even appear? For smaller black holes, it's simple. Star goes boom, while the core goes moob. But what about these gargantuan monsters? No star can possibly result in a black hole this big. Scientists think that their origins are ancient. When the first black holes had formed shortly after the Big Bang, they would consume the nearby gas clouds. In the process, they would release radiation that would heat even more neighboring gas clouds. As they got heated, they collapsed easier and become meals for the black hole. This is why the primordial black holes were thought to grow at an exponential rate, getting to tens of billions of solar masses, and becoming the centers of the galaxies that we see today. But there is a small issue. Scientists have estimated that ultramassive black holes have an upper limit to mass, 50 billion solar masses. Once one gets to this size, it would consume the unstable part of the accretion disk around it, leaving only the stable part, which would start orbiting the black hole instead of falling inside. So here's the problem: Phoenix A weights 100 billion times more than the Sun, which contradicts the practical limit of 50. So what's going on here? The answer to it is the good old, we don't know. One of the most probable explanations is that another huge monstrosity collided with Phoenix A, resulting in the second hypermassive black hole known to break this limit to this date. First is Ton 618 with a mass of 66 billion solar masses. Will we find bigger ones? Probably yes. Do they exist? Certainly yes. Considering that the universe is infinite in size, there might very well be cases in which 2, maybe 3, or even more gargantuan holes collide and result in monsters with the mass well above 100 billion suns. There is no theoretical limit to that. But even these seemingly endless behemoths are not eternal. Everything slowly marches towards death, and that includes black hole. They slowly lose mass by evaporating due to Hawking radiation. But this is an incredibly slow process. It would take 10 to the power of 100 years for Phoenix A to completely evaporate. That's 10 followed by 100 zeros. The universe has existed for only this much. So there is still a very, very long way until everything in the universe decays. And in these end times, black holes might very well be our final homes. But hey, don't be sad. You'll be dead by then. If you enjoyed this video, don't forget to give it a thumbs up, and consider subscribing to our channel for more exciting content on science, astronomy, and beyond. And as always, thank you for watching.